You know that feeling, right? When you're facing a choice, and even though a gamble looks great on paper, your gut just tells you to play it safe. Well, it turns out there's a fascinating mathematical story behind that feeling, and today we're going to dive right in. Okay, so take a second and really think about this. On paper, the math is simple, right? The average payout of the gamble is $100. That's double the sure thing. And yet, a lot of us, maybe most of us, feel this pull towards that guaranteed 50. So what's going on here? See, that little bit of hesitation, that's not just you being weird. It's not random at all. It's actually a window, a peek into the hidden shape of your own preferences, how you personally value money and risk. And today, yeah, we're going to map that thing out. All right, let's kick things off by digging into the fundamental idea that's really driving these kinds of decisions. Okay, so here's the textbook definition. That term, expected value, it's just a fancy way of saying the average payout of the gamble. So in that first question we asked, the expected value was $100. Simple. And if you found yourself leaning towards the guaranteed 50, well, congratulations. You were just showing what's called risk aversion. This really hammers the point home. Let's forget about the $50 for a sec. What if the choice was between that same 50-50 shot at $200 or a guaranteed no strings attached $100? Now the average is exactly the same. A truly risk-averse person, they're taking the 100 every time. You're basically paying a premium, a little fee, just to get rid of the uncertainty, to avoid that chance of walking away with nothing. So the big question is, how do we actually model this stuff with math? Well, we use this cool tool called a utility function. And don't let the name fool you, it's really just a way of mapping how much happiness, or utility as economists call it, you get from different amounts of money. And this right here, this gets to the heart of what it is to be human. The sting of losing $50, man, that hurts way more than the thrill of finding $50, right? And think about it on a bigger scale. That first dollar you ever earned probably brought you a ton of happiness. The millionth dollar? Not so much. It's a classic idea in economics, diminishing marginal utility. And bam, this is where it all comes together. That feeling we were just talking about, that each new dollar is worth just a little bit less than the one before it, that actually gives our utility function a very specific shape. It creates this curve that starts steep and then flattens out the more money you have. And in the world of math, that downward curving shape has a name. It's called concave. Okay, so really, these three things you see here, they're just different ways of saying the exact same thing. They're like three sides of the same coin. If you're risk-averse, it means your utility function is concave. And if your utility function is concave, it means the amount of guaranteed money that would make you just as happy as taking the gamble, well, that amount is always less than the gamble's average payout. And that special amount, we call it your certainty equivalent. It's what that gamble is really worth to you. All right, so this leads us to the next logical question, right? We know that people are risk-averse, but can we actually measure how risk-averse they are? Like, can we put a number on it? Well, it turns out we absolutely can. I mean, it sounds kind of tricky, doesn't it? How do you measure something so subjective? You might be super cautious while your friend is a total daredevil, a huge risk taker. We need some way to boil that difference down into a single comparable number. And here's the solution. It's this really elegant formula called the Arrow-Pratt coefficient. Now, don't let the calculus scare you. The idea behind it is actually pretty straightforward. First, you measure the curvature, basically how sharply your personal utility curve bends. The sharper the bend, the more risk-averse you are. Second, you normalize it. This just makes sure it doesn't matter if we're talking about dollars or euros or yen, the number means the same thing. And finally, you just flip the sign. That way, a risk-averse person gets a nice positive number. Easy. And that's it. It's really that simple. A higher number just means you're more risk-averse. It means you demand a bigger reward to take on the same amount of risk. You can almost think of it as the price tag you put on dealing with uncertainty. And that's an incredibly powerful tool, right? It lets us compare different people or even track how your own risk aversion changes over your lifetime. Okay, cool. So we've spent some time analyzing the person making the choice. Now, let's flip the script. Let's analyze the choices themselves. How can we look at two different gambles and say, yeah, this one is objectively better, or this one is objectively safer? So this table lays it all out. There are basically two main ways to do this.
The first one is called First Order Stochastic Dominance. Think of its motto as unambiguously better. It's a no-brainer. One option is just flat out better in every way. Everyone, and I mean everyone, who likes money is going to choose this one. Then you have Second Order Stochastic Dominance. This one's a bit more subtle. Its motto is unambiguously safer. This is for when two gambles have the same average payout. The one that's less spread out, less volatile, well, that's the one every single risk-averse person is going to pick.
The fancy technical term for what's happening here, making a gamble riskier without changing the average, is a mean preserving spread. It's a bit of a mouthful, but the idea is simple. You're just taking the possible results and, well, spreading them out. You're pushing them farther apart, making it more volatile, but keeping the center of gravity, the average, in the exact same spot.
Okay, let's make this super concrete with an example. So, step 1, we start with a really simple gamble. 50-50 shot at either $2 or $3. The average? $2.50. Easy enough. Now, step 2, we spread the outcomes. We take that $2 outcome and replace it with its own little gamble, a 50-50 shot at $1 or $3. See how we did that? Then, step 3, we do it again. We take the $3 outcome and spread it into a 50-50 shot at $2 or $4. So what's the end result? Step 4. We now have a new gamble with 4 possible outcomes. And get this, the average is still exactly $2.50, but it's way more spread out. It's riskier. That is a mean preserving spread in action. All right, for our final piece of the puzzle, let's tackle one of the most fascinating questions in this whole field. How does our wealth, how much money we have, change our relationship with risk?
I mean, it's a super common idea, right? And it just feels right. A billionaire can throw a few grand at a risky startup and not even blink. But for someone living paycheck to paycheck, that same $1,000 is a huge, huge deal. The stakes are just different. So, economists have 2 really specific ways to talk about this. First up, you've got decreasing absolute risk aversion. This is the simple one. It just means as you get wealthier, you're willing to risk more absolute dollars. You'd be comfortable with a $1,000 bet you wouldn't have been before. Then there's decreasing relative risk aversion. This one is an even stronger claim. It says that as you get wealthier, you're willing to put a larger percentage of your total net worth into risky stuff, like the stock market. And you know what? Both of these ideas are considered really solid assumptions about how people generally behave. They're not just theories. They're the building blocks for economic models that help us predict real-world stuff, like how people invest for retirement or why the market for insurance looks the way it does.
So, if there's one big thing to take away from this section, it's this. Your relationship with risk isn't set in stone. It's not some fixed part of your personality. It's dynamic. It changes and evolves with your circumstances, with your wealth, your goals, where you are in life. It's constantly in motion. So the next time you're faced with one of these choices, a sure thing versus a gamble, you'll have a much better idea of the hidden math going on inside your own head. You've got the tools now. So my question to you is, how are you going to use them to look at the risks you face every single day?